In this video, we'll take a look at creating a simple sequence application using App Inventor. First, let's look at the software development cycle. This is also called the program development cycle. And I have here listing the steps for creating an App Inventor program, but these steps work regardless of what type of programming language you're using. Real quickly, the first step is to gather the requirements of the project. What's the project supposed to do? Secondly, we'll work through the logic by creating an algorithm, listing the variables, designing the GUI. You can design the GUI just on paper and pencil. After you've got that thought through, you will go in and you'll open up App Inventor and you'll create the components, add the components to the screen, go into blocks and code your blocks. After you're done with that, you need to test, and we'll talk a little bit about the steps for testing. And then you will deploy. If all tests well, then you'll deploy your application. So for Android applications, that may mean just creating that APK file, sending it to a friend, or it could be putting it up on Google Store. Then the last step is maintain. So just because you've got it deployed doesn't mean all is perfect. Maybe you get feedback that something needs fixed. So that's the maintenance phase, and if you find that something does need fixed, you might find yourself starting at step 1 all over again. We'll step through each of these, well, the first 4 steps, with a sales tax calculator. Step 1 was gathering the requirements. How do you do that? Well, you get together with the people that want the application built and you interview them. You can also look at mock-ups of reports or output. And looking at what they want gives you an idea of how to get started to get there. And in a more complex application, you might have project managers and meet with the stakeholders and develop something called a requirements specification document. So you would learn more about this if you continue in programming in a systems analysis course. For us, it's just going to be the teacher giving you the requirements. It'll look a lot like a word problem. For the sales tax calculator, we're going to have the user input a retail price, and the sales tax will be calculated and displayed. The sales tax is 7%, and the sales tax will be added to the retail price, and a total will be displayed. So what are the steps to develop the logic? One good method is called the IPO method, and IPO stands for input process output. But even though O is last, that's where you actually start. What is the output? What do we want to happen with this program? For this program, we need to know sales tax and how much is owed once the sales tax is added. What input is needed then to get to the output? So now we're at the I part of IPO. Well, we need the retail price. And finally you go, okay, so how do we get from input to output? What are the processing steps? And I show here in number 3 a couple of assignment statements. So I have an assignment statement calculating the sales tax, and then I have an assignment statement adding the retail price to the sales tax. From there, I've got some pseudocode. Okay. Now, pseudocode means fake code. So the way I pseudocode may look a little bit differently than the way the author pseudocodes or some website pseudocodes. I have determined when I looked at this IPO method that I have 3 variables. I have a sales tax variable, a total variable, and a retail price variable. Here I am declaring 3 variables. This declaration just lets RAM know that I'm going to have these variables, set aside some space in RAM for it, and it will hold real numbers. So real numbers will have decimal places. Now in simple sequence, after declaring the variables, you just step through, get the input, do the processing, and then the output. So what was the input? Well, the input was retail price. So that's what we're doing. Now in pseudocode, you can write the word get retail price. You might write input retail price. It doesn't matter. The idea is we're getting a value into the retail price variable. Is that all the input? Yes. Okay, now let's do the processing steps. So here are our processing steps, which is something I've already got from step 3. I've just simply copied those assignment statements here. So we know retail price, let's say it's $100, right? So if retail price were $100, then we would multiply it by that, and we would get a result of $7. 100 times 0.07 will be 7, and that 7 then will be stored in the variable sales tax. Okay, in the next statement then, that $7 is added to the 100 that's in retail, and that'll give us $107, and that will be stored in the variable total. So we're done with the processing, and now finally we got the output. And so we're going to output the sales tax, $7, and the total, $100. A little bit more about pseudocode. You will see that the author introduces this in section 6.5 of the text. I did mention that pseudo means fake. It's not a real programming language, and you're not worried about syntax. Syntax means the rules of the language. So when you're programming, you have to worry about putting the semicolons in the right place, using the correct operators. When you're pseudocoding, you're just like, let me think about the logic of the algorithm. So I got this from a textbook. I really liked how this author defined pseudocode as part English and part structured code. So what does that mean? You're going to see that you're going to have to indicate in your pseudocode when you're going to branch into an if, or when you're going to go through a loop. That's structured code, but it's written in regular English. Okay, my step 2A said, now that I've got my pseudocode here, what's my data? What data do I need? So the data that I'm using is retail price, and I think in my program I'm going to create a local variable, I'll call it retail price, sales tax, local variable called sales tax, I'll need another local variable called total, and for the tax rate I'm just going to use the literal 0.07. Okay, now that I know my variables, and here's my pseudocode again, I want to introduce something called a toe chart. Now, a toe chart is very helpful when you're starting to design a GUI. It helps you to think through what components you need to do based on the tasks that you're doing in your pseudocode. Okay, so here's one task. One task is I got to get the retail price. So I'm going to copy that task right here. And I decided, well, for that task, I'm going to add an object, and I will call it retail price text box. Well, here's another task down here that's related to the GUI. I need to display the sales tax. So for that task, I'm going to add a label. Now let me tell you why a label. A label is good for output. Okay, a text box, input, because the user can click in and enter data, and a label is good for output. You can also use a text box for output. However, in App Inventor, you will see over in the properties when you have the text box selected that there's an enabled button. So take that enabled check out of that checkbox. And here's the next task. We're going to display the total. So to do that task, I'm going to have another label, and I'll call it the total label. Finally, the E part of toe chart is the event. So what event do I need to do? Well, I need to be able to calculate this. I need to be able to go from input to output. And so I need something to get all this started. I'm going to add a calc button. I'm going to call it calc button. And when the click event happens to that, we'll run the code that's going to do this logic. So using that toe chart from the last slide, you can go ahead and design your components on the screen. So from the toe chart, you'll see that I have. Here's my text box for getting the input. This here in the gray is the label for outputting the sales tax. Here's the gray and the label for outputting the total. In addition, I've added 3 labels, and these are for prompts. So the user doesn't just stare at a blank text box. They know, oh, I'm supposed to enter the retail price here. And here's my button that we had to cause the click event to get the whole pseudocode, the whole logic to start to execute. Okay, so then after you're all done, you can take your pseudocode, you've got your design all done, you can take your pseudocode and relate it to the blocks here. So let's see what's happening. When this event occurs, okay, what event? Well, when the button is called calc button is clicked, all of these items happen. Now look at this right here. We have 3 variables declared: retail price, sales tax, and total. And that's what we have right here. We have 3 variables: total, sales tax, and retail price. They are initialized inside the click event for the button. So they're created and they're initialized. They're local. So every statement that has to use those variables, they're tucked inside this part of the variable declaration. Now, I need to get the retail price. Okay, so that's input. So here is my text box, okay, called retail price text box. I had that in the toe chart. And it's the text property that's holding the data the user inputs. So I have an assignment statement. This is an assignment statement in App Inventor that says set retail price to, and then I've plugged in this block that is the text property, the text box. So that takes care of this statement right there. Now the next statement in my pseudocode, I assign to the sales tax variable the retail price times 0.07. So again, we have another set statement. So it's another assignment statement. This time we're assigning to sales tax. Now you'll notice a blue block. So this blue block means we're going to be doing a mathematical expression. In fact, we're doing multiplication. And the first operand is the contents of this variable. Okay, right there. And the second operand is the literal that we decided to use right there. Now we'll go ahead and we'll do the third assignment statement, which sets the total. Okay, again, the total is going to be a mathematical operation. And what are we going to do? Well, we're adding the content of the sales tax variable and the content of the text box. You can also change this. This could also say the content of the variable retail price. Okay, so that takes care of these 2 statements, and now we're on the output. So my output was into a label. So the text property of a label is what displays to the graphical user interface. And I'm doing an assignment statement. We're assigning to the text property the value of sales tax. This will output sales tax. It's the same as writing display sales tax in the pseudocode. Now you notice that I used format as decimal number. So when it outputs, it will always display 2 decimals, which is good for currency. Again, display total. I'm going to set the text property of total label. Use format decimal number. Here's my total, and here's formatting to do decimal places. So if you think you're all done with your code, what's the next step? Test. So in testing, you should develop test cases. And this is on page 189 of the textbook. You're going to have a discussion over it. And you should run your application using those test cases. That wraps up this little introduction to the building blocks or creating simple sequence application in App Inventor. Next one, we'll step through creating one. We'll get into App Inventor and create one.